Hey guys, I hope you're doing well today. We are going to check out some concepts and some skills necessary for success in the geometry section and the chapter 2 material that you'll be working on in this course. So, as you watch the video, take some notes on these different concepts so you'll be able to complete the lab assignment in my math lab and the homework assignments associated with this particular lab. Okay, so the first thing we're going to look at is something that you're familiar with, but you may have forgotten about regarding the different place values. Because you're going to be doing a lot of rounding in this class, and you need to know which position they're referring to when you're being asked to round to a certain spot. So what I've done is I've copied this place value chart to remind you of what the different place values are when you have a number. So let's suppose I have this number, 37,256.10489. So let's assume I have that number. Let's just first identify the value in the different positions listed below. So what I would do is I would just take this number and write it in the different positions. So let me catch, yeah, I think blue will be okay. 10489 is after the decimal place. So this is 10489. And before the decimal place, we've got a 6, a 5, a 2, a 7, and a 3. So now I can very easily identify the different place values. So if I was asked to determine the value in the hundreds position, notice that the guys on the left do not have the THS, but the ones on the right do have the THS on the end, and so that tells you if we're tenths or hundredths, we're on the right-hand side of the decimal point. If it doesn't have that, then we're talking about values on the left-hand side of the decimal point. So the number in the hundreds position would be 2. You can very easily identify these, but I'm going to quickly go through it. In the hundredths position is 0. Thousandths, it has a THS, so that would be 4. 10,000ths, that would be the number 8. The tens position would be a 5. And the 100,000ths, well, there went off of fireworks. As you can tell, this is July 4th. We might be getting a few more of those during this video. Okay, back to 100,000s. 100,000s would be this position, but guess what? I got no values, so I wouldn't have an answer for that one. So first thing is to identify the different place values. Now what we're going to do is look at rounding. And this is important for the rounding aspect. So we're going to take the same value we had earlier, and we want to do some rounding on that value to the nearest place value indicated here. Okay, so I would like to take this number and let me get a better blue. Kind of like that blue better. Okay. We're going to round this number to the nearest tens position. So we first have to be familiar with, well, where is the tens position? In this case, it would be the 5. So the 5 is in the tens position. So to round it to the tens position, I have to look to the number to the right of it. So the number to the right of 5 is a 6. And that's the number I use to determine if I keep it a 5 or if I bump it up by 1. And so here's a rule a student told me. If the number to the right is 5 or more, then give it a score. That means you just add 1 to it. So the number to the right of 5 is 5 or more, so I'm going to give that 5 a score, and I'm going to round that 5 up to 6. So the value would be 3, 7, 2, 6, changing that 5 to a 6, and then a 0. And there's going to be nothing behind that 0 because we're rounding to the nearest tens position. So it's just going to stop right there. Nothing else behind it as far as numerical values go. But we need to keep this as its original 37,000. Okay, so now I want to round it to the nearest hundreds. There's no THS, so I'm going to find the 100 position, which is right there. 2 is in the 100 position because that's 256. Now the question is, do I keep it a 2 or do I bump it up by 1? Well, if the number to the right of 2 is 5 or more, then I'm going to give it a score. So the number to the right of 2 is 5 or more. It's 5. So I'm going to bump it up by 1. I'm going to give it a score. So this will be 373. And then I'm not going to put the 5, 6. I'm going to put 0, 0. I have to always be in that 37,000 range. Or maybe 40,000, depending on what I'm asked to, which place I'm asked to round to. So what if I've got a problem and it says, okay, round your answer to 3 decimal places. Well, what I'm going to do is I'm going to look at 3 decimal places. 1, 2, 3. So the number 4 is the one in question. Do I keep it a 4 or do I bump it up by 1? Well, what's the number to the right of it? The number to the right of it is 8. And since it's 5 or more, I'm going to give it a score. So that 104 changes to 0.105. Now we're going to keep everything to the left of it as it was. So we rounded to 3 decimal places, and the 4 was in the 3rd decimal place. Let's round it to 2 decimal places. So the value in the 2nd decimal place would be 0. So I have to decide, do I keep it as 0 or do I bump it up by 1? Well, the number to the right of it is not 5 or more, so I'm not going to give it a score, and I'm just going to stop it right there. 2 decimal places, the last value would be 0. So 37256.10. Okay, let's go ahead and round again to, in this case, the 10 thousandths. Well, I've got to be familiar with my place value up here, values up here to find the 10 thousandths position. And you'll see up here that 8 is in the 10 thousandths position. So I'm working with this 8 right there. Question is, do I keep it an 8 or do I bump it up by 1? Of course I'm going to bump it up by 1 because the number to the right of it is 5 or more. So that 8 is actually going to become a 9. So the value will be 37256.104, and the 8's going to jump up to a 9. Okay, let's do this to the 10,000. Notice there's no THS on that, so we're going to go to the 10,000 position. Well, this 7 is in the 10,000 position. Excuse me. It's not the 7. What would it be? Okay, where's the 10,000? It would be the 3. So it's the 3 I'm concerned about this time. So the 3 is in the 10,000 position. So I look at the number to the right of it. And if this number is 5 or more, I'm going to give the 3 a score. And it is. It's a 7. So I'm going to round that 3 up by 1 to a 4. Now, what's the rest of it going to look like? 4 is in the 10,000 position, so this would round to 40,000. So 37,256.10489 rounded to the 10,000 position would be 40,000. Okay, let's see what else. Oh, I want to round it to the tenths position. Where is the tenths position? The tenths position is right here. So it's basically rounding it to 1 decimal place. Well, what do? Do I keep the 1 or do I bump it up? I'm going to keep it because the number next to it is not 5 or more. So the rounding to the tenths position, I would stop it right there. So 37256.1. All right, and let's look at the last one. The last one, we want to round it to the thousands. So the thousands position would be this 7. So the question is, do I keep it a 7 or do I bump it up 1? And I'm not going to bump it up because the number to the right of the 7 is not 5 or more. So rounding this to the nearest thousand, it would be 37,000. Period. And you could put a decimal if you want there with a 0. Not that important. But if you want to keep track of your decimals, that's where they would be. Same thing here. You can put a 0.0 there if you wanted to. I hope this gives you just the hang of rounding, because we're going to be doing a lot of rounding of our values in this class because we're going to be dealing with real life numbers and we're going to need to do some rounding on those real life values. All right, so let's check out what other skills we need to know. We need to know how to convert a fraction to a decimal. Well, all we have to do is use our calculator to determine the decimal values and then round it to the nearest value indicated. So we want to divide these out and round to 3 decimal places. So just pull out a calculator, whichever calculator you happen to have, and let's just divide 230 by, in this case, 1732. Dividing that out gives me this decimal value, but I want to round this to 3 decimal places, okay? So 3 decimal places means the 2 would be the value in question. Do I keep it a 2 or do I bump it up to a 3? Well, since the number to the right of it is 5 or more, I'm going to bump that 2 up to a 3, and this value would be 0.133. And since there's a negative in front, my answer would be negative. Just making sure I remembered that number correctly. Do the same thing with this one. See what you get and round it to 3 decimal places. Take a look at what we have. 0.00833333. I want to round it to 3 decimal places, so 8 is in the 3rd decimal place. So the question is, do I keep it an 8 or do I bump them up to 9? Well, since the number to the right is not 5 or more, the answer to this would be 0.008. So very easy to convert fractions to decimals. The next concept we need to recall on how to work with would be mixed numbers. When you're working with mixed numbers, it is best to convert those to improper fractions. So let's review how to convert mixed numbers to improper fractions. So my first one is 3 2/5. You probably remember how to do this, but let me just chart it here in maybe red. The way we convert these is we take this bottom number here, and in this case it's a 5, take that number, whoops, waited too long, multiply it by the 3, and then add the 2. So I would have 5 times 3 would be 15 plus the 2 all over 5. So this would result in 17 over 5. So we multiply the denominator times the whole number and then add the numerator to it. So if I did the same thing over here, since it's a negative in front, my answer is going to be negative. But I would multiply 12 times 11 and then add 5 to it. So 12 times 11 plus 5, and that's going to all be over the denominator of 12. Notice the denominator here of 5 carries over, the denominator of 12 carries over. So the answer there is negative 137 over 12. Again, I'm just jogging your memory on some of these concepts that you may have forgotten about, because math is one of those subjects where if you don't use it, you lose it. But it's not that difficult to get it back. All right, so let's check out and review how to multiply fractions. Well, that's the easiest of all the operations in working with fractions, because all you do is you multiply straight across. Numerator times numerator, denominator times denominator. Be careful with your signs, because our old sign rules apply, and since I'm multiplying a negative times a negative, my answer is going to be positive. Also, keep in mind that you can reduce your fractions either before or after your multiplication. Let's just go ahead and multiply straight across. 9 times 5 is a 45. 4 times 3 is a 12. And then take a look at this to see if you can simplify or reduce it. Well, what I noticed over here is that 3 would actually divide into that 9. So there's some reducing I could have done earlier, but I could do it now. I could just divide them both by 3 to get my final reduced answer. So what is 45 divided by 3? Should be 15, and 12 divided by 3 should be 4, and that would be your final answer. So you could either reduce before, divide 3 into the 9, and 3 goes into 9 3 times. So I'm left with 3 times 5, which is 15, over 4 times 1, which is 4. What if I needed to multiply fractions that involve mixed numbers? Well, you guessed it. We're going to do exactly what we did over here. We're going to take those mixed numbers, change them into improper fractions, and then multiply straight across. So take a second to do that. See if you get 91 over 12 for that answer. 3 times 4 is 12, plus 1 gives me 13. 2 times 3 is 6, plus 1 gives me 7. And I notice that there's nothing common across these guys that I could reduce it by, so I just went ahead and multiplied straight across. 91 over 12. Next operation on fractions. What if we have to divide them? You remember the rule? We invert the second fraction and change division to multiplication. So what do I mean by inverting the second fraction? Well, here's my second fraction right there. So I'm going to invert him. Basically, that just means flip him over or take his reciprocal. So 5 over 3 becomes 3 over 5. And we change the division to multiplication. So we invert and change division to multiplication. Now it just turns into one of our previous problems where we multiply straight across. So 9 times 3 would be a 27, and 4 times 5 would be a 20, and that does not reduce because I looked between the 9, the 4, and the 5. Those guys had nothing in common. The 3, the 4, and the 5, the numerator and denominators have nothing in common. So that would be my final answer. Let's divide the next one. Now here I have a negative fraction divided by a positive fraction, so my answer is going to end up being negative. But let's do the invert multiply. Negative 5 over 4 times 3 over 5. Invert that second fraction. I know my answer is going to be negative, but I also notice that this 5 and this 5, the numerator 5 and the denominator 5, cancel out. So I can reduce it right now, and I end up with, what is my answer? Well, it looks like I only have a 3 at the top, a 4 at the bottom, and that would be a negative 3/4 since I had a negative 5/4 divided by a positive 5/3. And a negative divided by a positive is going to be negative. Okay, so negative 3/4 on that guy. So last couple of topics we need to look at would be scientific notation and then solving some simple algebraic equations. A little background music for you there. Somebody on a motorcycle. So let us recall how scientific notation works. We're going to be using scientific notation because we'll be comparing maybe some really large quantities. And when you're talking about distance from the Earth to the moon or to the sun, those are really large numbers. And a lot of times we use scientific notation to represent really large or really small numbers. So here is a regular number, 25 million. Okay? That notation is obvious. Scientific notation over here on the right looks like this. So 25 million is 2.5 times 10 to the 7th power. How do we get to that notation? Well, first thing we do is recognize in the 25 million, where is the decimal point? It is at the end. If you don't have a decimal point, it is always at the end of a number. So I've got 250000000. I need to move that decimal point to the left until I get to a number that's less than 10. I know that seems weird, but that's how our scientific notation works. So I need to take that decimal point and stop him between the 2 and the 5, so I get the number 2.5. I'm not going to stop it after the 5 because that would be 25 and that number is bigger than 10. So this front number right there needs to be less than 10. So that's why I stopped it between the 2 and the 5. And I've got to also be careful to not go beyond that 2 because if I do, it would be less than 0. And actually what I want is that number to be less than 10, but I also want it to be bigger than 0. If that makes sense. So let's move it. I'll move it 1, 2, 3, 4, 5, 6, 7. I moved it 7 positions. Let's look at the scientific notation. It is 2.5 times 10 to the 7th power. Well, where did 2.5 come from? It came from the fact that I stopped my decimal between the 2 and the 5 to get a number between 0 and 10, and I had to move it 7 positions. So that 7, your exponent on the 10, represents how many spaces you move the decimal point. If I were given a number in scientific notation like this one, 2.5 times 10 to the 7th, to convert that guy to regular notation, this 7 tells me to take my decimal place and move him 7 to the right. 1, 2, 3, 4, 5, 6, 7, and then fill it in with zeros. And when I do that, I will get my original number, 25 million. Let's try it again. Okay, I've got a regular number of 0.000376. So I've got my decimal place. I need to move him somewhere around the 3, the 7, or the 6, so I get a number that's between 0 and 10. So I'm going to move it. Where do you think I'm going to stop it? Am I going to stop it before the 3, between the 3 and the 7, after the 7? It's going to have to be between the 3 and the 7, because that number up front, when you're in scientific notation, the number up front needs to be a number between 0 and 10. So I stop the decimal between the 3 and the 7 because that'll give me 3.76. And that's a number between 0 and 10. So it's greater than 0 but less than 10. Now, I'm going to multiply it by 10 to a power. So how many places did I move it to get between the 3 and the 7? And I moved it 1, 2, I moved it 3 places to the right. So the exponent on 10 is going to be 3. However, it's a negative 3. This was a small number that I was converting to scientific notation, so that exponent is going to be negative. So if I were given that in scientific notation, 3.76 times 10 to the negative 3, and I wanted to convert that back to regular notation, that 3 tells me how many places to move my decimal, and the negative tells me move it to the left. I'd move it to the left 1, 2, 3 places, drop my decimal, and then include those zeros. So that's how we'll convert both ways, from regular notation to scientific notation, or scientific back to regular notation. Let's look at the last concept here, which is solving some simple algebraic equations. We're not going to do a bunch of algebra in this class, but we will have to solve some simple equations. So I want to review those concepts. So suppose I had an equation of 10x equal negative 5.8967. There's my equation. I want to solve it for x, so do you remember what to do? Since it's 10 times x, I have to undo that multiplication with a division. So I would divide both sides by 10. By doing that, the 10 divided by 10 gives me a 1, so I'm left with a 1x. So I've basically got x by itself. And then if I divide the negative 5.8967 by 10, I'll end up with a negative 0.58967. And you can check that on your calculator. Just take that value, 5.8967, and divide that by 10, and you'll get 0.58967. So yeah, use your calculator. Anytime you need it, use it. Okay, here's a case I want to solve for m. And the equation is 0.05 times m equal 15. So to get m by itself, I need to undo the 0.05 times it. And I will do that just like I did before. I'm going to divide both sides by 0.05. That will give me a 1m, or it's the same thing as m. And so I'd go to my calculator and take the 15 and divide it by 0.05. That gives me 300. So the value of m is 300. And remember, you can always check your answers when you're solving an equation. Just take that value, plug it back in place for m, multiply it by 0.05, and you should get the number on the right, 15. So remember that you can always check your answers. 2 more equations to solve. These are set up like proportions. Is that ringing a bell? I'm solving an equation, so I can use this, and they're set up as a fraction equal to a fraction. So you might remember that you can cross multiply to solve an equation that's set up as a fraction equal to a fraction. So I would multiply 9 times 4, which would be 36, and set that equal to 6 times t. So I've got 4 divided by 6 equal t divided by 9. And I want to solve this for t. So I did a little cross multiplication. The denominator on the right times the numerator on the left. The denominator on the left times the numerator on the right. So if 36 is equal to 6 times t, to get t by itself, I have to undo the 6 times t, and the opposite of 6 times would be a division. So the two 6's cancel out. 6 divided by 6 is 1. So I'll get 1t equal to whatever 36 divided by 6 is, and it's actually 6. So we get t equal to 6 in this case. Take a second, work the next one, pause the video, see what you get, and then turn the video back on and see if you're correct. So see if you get y equal 42. Look over this. If you have any questions on any of these concepts, you email your instructor. I am willing to help you with any questions you may have. But if you're okay with these concepts, then you will have the necessary skills for success in the geometry and the Chapter 2 material. So let me know if you have questions.